Okay, so strontium nitride. As I said before, this is an ionic compound. So the first bit, the metal, usually there's just one of it. So just put the strontium first, and then how many nitrogen ions will there be? I think it's 2 as well. So what are you going to do then to this formula to balance it out? Strontium, the charge is 2. Do you know the charge of nitride? So the charge of nitride then is -1. Charge of strontium is 2. So what do you do to balance it out?
Wait, where do I put the -1 though? Do I even put the -1 nowhere? Like,
No, when you're writing a compound, you don't need to put the charge numbers because when you add them together to the right amounts, the total charge is 0. It's balanced out, you know. So you need to do the number of nitride ions because we've decided it's not 1 because the charge of strontium is 2, nitride is 1. You need the total to be 0. So how many nitrides do you want to have?
I think we need 2 nitrides.
Yeah, that's correct. Good job.
So we just leave it like that?
No. Then you do the subscript and say 2 to show there are 2 nitride ions. Okay, next one, lead sulfite. Now you can actually look on your little cheat sheet on the side, common polyatomic ions. Sulfite is a don't ion made of other ones. So you can see over there how to write it and what its charge is. It's on the slide. No, it's not in the periodic table. It's on the slide. See, the column that says common polyatomic ions. You can start by writing lead off because you know there's only going to be one lead because it's a metal. And at least to start, you should assume there's only one. But then we can multiply later if we need to. Okay, you can write sulfite first though, I guess. SO, but that's not the whole thing. You see what sulfite is? It's SO3. It's 1 sulfur and 3 oxygens as 1 ion. So do you see what the charge of sulfite is in the table?
Yeah. It's -2.
Yes, it is. So how many lead do we need? You don't write the charge when you write out the whole formula, remember? You don't write the charge. You just need the number of ions. You're going to write the 2-. You leave the 3 though, because that's part of the name of the ion. Yep. So that's 1 sulfite. We're good. Now write in lead. Do you know the atomic symbol for lead?
No, that's why I was going into the
okay.
The table to try and find out where lead is.
It's PB. So PB, peanut butter. Yeah.
Oh, okay. Lead is peanut butter. Wow.
Reduced. Yeah, they don't tell you that, but okay. Well, it's lowercase b because it's 1 symbol. Okay. So the thing is, this is not balanced yet. Do you know why? No, there's only 1 sulfite.
Oh, right. Sorry about that. Because there's 2, because the negative charge of sulfite is -2, so
the name of the compound you're making will give you a clue as to the charge of the metal.
Oh, you mean the Roman numeral?
Yeah.
It's 4 or 6?
Yeah.
I don't know. Is that 4?
No, it's 4. Yeah, it's 4. It's lead 4 sulfite. So the charge of lead in this case is 4.
4.
So what's the total positive charge of this compound?
+4?
Yeah, because the charge of lead is 4, and that's the only metal here. And then what's the negative charge that we have going? So far, just 1 lead and 1 sulfite.
It's -2 for sulfite.
Yeah, but that's not balanced. We have +4 and -2. Remember, it's got to be 0 total. So what do you want to have more of? You can multiply, either one of these.
It's only logical that we need more of sulfite.
Yes. How much more? How many sulfite ions do you need here?
Then 2 or?
Yeah. Well, no. Yeah, it's 2. And you see why. Lead has a charge of 4. In this case, according to the name, lead 4 sulfite. And according to the little table you have on the side of this slide, the charge of sulfite is -2. 4 and -2 times 2 balance out. Because you have 2 sulfites, the total negative charge becomes -4. So you have 4 and -4, and it's balanced. So you need 2 sulfites, 1 lead and 2 sulfites. You see what I'm saying?
Yeah. So then where do we put that in?
You need to put big parentheses around the SO3 and then do another subscript 2. Awesome. So yeah, we have a positive charge of 4 from the lead and 2 times the negative charge of 2 from sulfite. So 4 minus 4 is 0, and we're all good. Okay. So now you have, excuse me, chromium 3 oxide. Off the bat, just write in the chromium and the oxide, and then we'll get to balancing out. So Do you know the atomic symbol of chromium?
The atomic number here for chromium is 24. So
Cool. The charge is not the same as the atomic number, though, just to make sure you know that. In this case, actually, do you know what the charge of chromium is? In this specific case,
no.
it's not related to the periodic table. It's on the slide. There's a hint here.
The charge is 3.
Yes, positive 3. So the charge is 3. And then write in the oxygen, write the O. Okay. Now, what's the charge of oxide, which is just oxygen by itself?
Oxygen.
What is the ionic charge of oxide?
-1.
It is -2, actually.
Oh,
So
yeah.
you have an oxygen of, well, actually, sorry. Oxide might be written as O2. One moment.
Yikes.
Oxide ion is, okay. Yeah, no, it's just O by itself. I was right.
Oh.
O2 is something else. Okay, so in this case, if chromium is 3 and oxide is -2, what do you need of each to balance it out?
Which are the two that I need to balance out?
You have 3 and you have -2. What do you need to multiply them both by to balance out? Well, you can't multiply them by the same number. There's no number you can multiply 2 by and multiply 3 by to have them be the same thing. They're different numbers. You have to multiply them each by a different factor, So 3 times what equals 2 times what? You got to make it the same. You can pick 2 different numbers, So yeah, we're looking for the lowest common multiple of 3 and 2. Do you know what that is? The lowest common multiple of 2 numbers is the lowest number that is a multiple of both of them, okay? And one way to find a common multiple, whether or not it's necessarily the lowest one, is to multiply the 2 numbers together. So a common multiple of 3 and 2 is 3 times 2, or 6. Excuse me, 6 is a common multiple. If the positive charge and the negative charge were both 6, we'd be balanced. So how many chromium 3 do you need for the total positive charge to be 6?
Wait, that would be 2 then. 2 more.
Yes,
then.
it would. Yeah. No, not 2 more, 2 total.
Yeah.
So 2 times 3 is 6. Yeah. So it's going to be CR2.
Yeah, CR2.
So the total positive charge is 6 now. And remember, the total negative charge of just oxide by itself is just -2. So what do you multiply that by to get to 6?
3.
Yes, so it's O3.
O3.
Great, done.